Alright, algebra. So I made a mistake, and when I left school today, I did not bring a copy of the homework with me. So what I'm going to do in this video is solve a problem or two similar to the type that are on your homework, and hopefully that'll be enough to help you through it. So the name of the game here is understanding structure. In a problem like this, there's several different ways you can start. But our ultimate goal is to get P all by itself on either the left or the right side of the equation. So I'm going to show you several different ways you could go about solving this example. We could start with our negative 14 and positive 4 and add 14 to both sides of the equation. So whatever I do to one side of the equation, I'm always going to do to the other. Negative 14 plus 14 is 0. We didn't do anything to the 5p, so that comes straight down. The equal sign comes straight down, and I've used red to highlight that the equal sign is really what's most important here. Everything we do is hinging on that equal sign. 14 and 4 added together makes 18. Didn't do anything to the 8p, so it comes straight down. Of course, if you add 0 to something, that doesn't change its value. So I've dropped the plus 0 and just gone straight to 5p. Thus far, I've got my constants all together on one side of the equation, but I've still got the problem of having p's on both sides. 5p's on the left and 8p's on the right. Since my goal is to get all the p's on one side of the equation, either the left or the right, I'm going to move all of the p's on the right side of the equation over to the left side by subtracting 8p from both sides. 8p minus 8p is 0p. Didn't do anything to the 18, so that comes straight down. 5p minus 8p, remember the integers worksheet, is negative 3p. And since I've got 0 p's, I may as well drop that all together and rewrite negative 3p equal to 18. The last step is to separate the negative 3 and the p. Since negative 3 and p are being multiplied, I'll divide both sides by negative 3. Negative 3 divided by negative 3 equals 1. All we're left with is 1p. 18 divided by negative 3 is negative 6. Since I've got the final answer here, I will put a box around it to show that I'm done with my work. So we've accomplished our goal of isolating p on one side of the equation and determining what it's equal to. If we take that value and substitute it into the original equation, we'll be able to demonstrate that our answer is in fact correct. 5 times negative 6 is negative 30 minus 14. 8 times negative 6 is negative 48 plus 4. Negative 30 and negative 14 together is negative 44. Negative 48 and positive 4 together is also negative 44. Negative 44 equal to negative 44, that's a true statement. So that tells us that this answer, p equal to negative 6, is correct. Now I'm going to stay with that same example, but I'm going to go about it in a different way. Instead of beginning by adding 14 to both sides, I'm going to start by subtracting 5p. 5p minus 5p is 0p. The minus 14 comes straight down. 8p minus 5p is 3p. And the 4 comes straight down. The 0p is unneeded, so I'll drop it and leave negative 14 equal to 3p plus 4. My goal hasn't changed. I still want to get a p all by itself on one side of the equation or the other. I've just changed the order in which I've gone about it. Now I'm subtracting 4 from both sides to handle the constants. 4 minus 4 is 0. The 3p, nothing was changed, so I bring that straight down. Negative 4 minus 4 is negative 18. Drop the 0 because it's unneeded. And then divorce the 3 and the p with division. And we get the same answer we did before. P is equal to negative 6, which we've already shown works. While it's not always true, a good rule of thumb is to handle all additions and subtractions first.